Paging is very popular in many of the operating systems, but along with this, there is one more concept called as segmentation. Segmentation is like this. Even though paging is dividing the process into pages, the problem is when we divide them into pages, sometimes what happens is two related pages might two related segments. Okay, what I can say is I should not use the word segment as of now. So two related parts of a program might fall in two different pages. Let us say you have a function f, okay, and now using this function f, if you have written this in many lines, then if you apply paging concept, it might so happen that the function might get divided into two parts, right? And now it might so happen that these two parts might map to only a single frame, which means in order to load these two parts, only one single frame might be allocated, right? Then what happens? In order to run this, first you load the first part, and then once you cross this boundary, you have to load the second part, right? So dividing the program or the process into pages might sometimes lead to division, which might not be meaningful, which means you might try to cross the boundaries, or your paging boundaries might try to divide the process in such a way that some useful things might fall in different places, different pages, which are supposed to be together, which is not meaningful. So in order to match the process to how we visualize it, to how we perceive it, to how it is called as user's view. See, user's view is different from the operating system's view. Operating system can directly see the process as pages and it can load it, but a user will always have a different kind of view, in which when we talk about a program, we generally talk about the functions in the program, isn't it? We say that it is main function, it is function f, it is function g, something like this, right? We don't talk in terms of the pages. So for users, to be meaningful for the users, we are going to divide the process into segments. So segments is actually close to what the users will think of a program, like this. So what this concept says is the entire process will actually be divided into not the pages, it will be divided into segments. For example, one segment can be the main segment, which contains the main program, and then other segment can be some user defined function, something like this, and other segment can be some library function, right? And other segment can be data part, and other segment can be stack, right? Then what happens is we load these segments in the main memory as a whole. So when we load this main, this segment called main, we load this entirely in the main memory. And when we load this entirely in the main memory. We are not going to divide this into any smaller parts, right? So now what is the advantage of having such a kind of segmentation is, or how to implement it is, once we are running some function, we need not worry about whether the rest of it is present in it or not. So if you generally call a function f, it so happens that we run it till the completion. Therefore, when you are running it, entirely it will be loaded into the main memory, and you need not worry about the page faults in the middle. And moreover, it will be meaningful for the user also. Then what we do is, whenever we try to load this, just like pages, we load the segments onto the main memory like this. Let us say this is the memory, physical memory in which main is loaded, right? And then this is called the base. Base means what is the starting point where you have loaded it, and this entire part is called as limit, or sometimes called as size. Okay, so base and limit are the two parameters which are associated with the segment. So every segment is going to be loaded at some point in the memory, and the base of that segment will say where it is starting from, and the limit will say till what part it is running, right? And for example, if we have the function f, if it is loaded from here, then we can say that this is the base and this is the limit or size. Okay, and now like this, in the main memory we are going to load all these segments. Then how to manage it, how to given a logical address, how can I convert into physical address? That is called memory management unit, right? Now here memory management unit will contain one table called as, just like page table, there will be a table called as segment table. And now this segment table will contain one entry for each segment present in this, and each page table, this segment table entry will contain, basically it will contain many parts, but the most important part is what is the base and what is the limit, right? So for example, now whenever CPU generates any logical address, it can be divided into two parts. One is what is the segment number that the CPU wants to access, and within that segment what is the offset, which means once you reach the segment, where do you want to, what word you want to access it, right? So CPU generates the logical address, and now logical address contains two parts. One is segment number and other is the offset, which means within that segment where we have to go and get the word from, right? Now by using this segment number, right, we go into that particular segment. For example, if you want segment, this is segment 0, this is segment 1, segment 2, segment 3, segment 4, segment 5, right? By using this segment number, we go into that particular segment and we get the base of it. Okay. Once we get the base of the limit, if the segment size is, let us say, 100 bytes, you should not ask for 1000 bytes. Depending on the limit of the segment or size of the segment, your offset should always be less than that. So we even perform a checking here, right? We take the offset and we perform a checking. So the limit, the offset of the word has to be less than the limit. Then only we are going to take the base and then add the offset, and we are going to get the actual whatever word we have, and we are going to get it, right? So that is how it is going to be acted. And now CPU, whenever it generates this logical address, it should even know where the segment table is stored. Just like page table, segment table will also be loaded in one particular page, right? So segment table will be loaded in one particular at one particular segment, not the page, at one particular point in the main memory, and that will be present in the starting address will be present in a register. This register is called as segment pointer, or segment table base. Let's not call it segment pointer, that has separate meaning in various operating systems. Let's call it segment table base. The segment table base will point to the starting address of the segment table, and now the segment number is nothing but from that starting address which entry you want to get into. And once you get into that entry, then you can get the base of it. This base will point to the starting address of some segment. For example, if this one might point to this, right? And then you can take the offset and get into that segment and get that particular word, and that is how the physical address is converted to logical address is converted to physical address. So here, how are you doing it? Given a logical address, we are going to present it to the memory management unit. In this case, memory management unit is nothing but segment table, right? Now logical address contains segment number and the segment offset, and this one will be given to the segment table, and from the segment table we get out the base, and then and from the logical address we take the offset and we are going to add it, and this will be physical address. This one will be given to the main memory and we get the required word. That is how the segmentation is implemented. And segmentation is not very popular. In the sense, pure segmentation is not very popular, but then some of the operating systems, some of the platforms, they support a combination of segmentation with paging. That will be interesting. We shall see what that is. Okay. Anyway, this is how segmentation is done. So what is the main advantage of segmentation? A user can look at the program in terms of the segments, not in terms of the pages, because looking at a program in terms of the pages is not logical for a user. User point of view is different and the system point of view is different, and segmentation is close to the user point of view and paging is close to the system point of view. Okay. Anyway, we shall combine paging and segmentation. That will be interesting, and that has been implemented in many of the operating systems. Okay.